tempting, of course, to speculate about going beyond the moon, further into space. The flight of Apollo 11, like earlier experiments, can certainly lead to more important developments very close to home, other than going deeper into space. The supposedly hostile environment of space has certain unexpected uses, which scientists hope to put to work. A whole series of projects on this order is now being worked out, generally referred to as the orbiting space stations. This was the subject of the program in the ABC television series Discovery, with Bill Owens reporting. Let's look at that now.
Where do we go after the moon? One of the suggestions for the future is to have a self-contained orbiting space station that could be sent aloft and positioned anywhere we wanted it. Here's a model of a proposed space station that could fit into the same Saturn rocket that carries the Apollo spacecraft. After being placed into orbit and separated from the rocket, the arms of the station would automatically unfold and lock together in the shape of a wheel. Fully extended, it would be 150 feet in diameter. Small rocket motors would impart enough spin to give the station an artificial gravity. Such a station would serve as a manned laboratory, performing experiments and scientific observations impossible from an Earth base. It could serve as a docking station for refueling and maintenance of other spacecraft, and a command and control center for more distant voyages, like a trip to Mars or Venus.
Cryogenics, I am assured by those in a position to know, is a science which is very vital to the Apollo space program. We have in our studio a couple of gentlemen who are qualified to talk at length about cryogenics. First of all, our commentator is Don Blake, or rather our demonstrator is Don Blake, and this is Edward McChandless, who will be our commentator on the question of, would you pronounce it for us and tell us what it is to begin, for those still struggling for the first cup of coffee this morning, gentlemen?
Yes, I would say that cryogenics is the science of cold, and the science of cold has been used to produce these cryogenic fluids, which Don is going to demonstrate in some rather simple experiments. This particular flask contains liquid nitrogen, which is the principal constituent of the air, as you know. This material, in its cryogenic form, is very much like water, as you can see. I should say more accurately, it's like boiling water. But it is at a very low temperature, about 320 degrees Fahrenheit below zero. At these very low temperatures, things really happen to materials. Don has dipped a carnation in liquid nitrogen, and you can see that something very unexpected happened. This phenomena of the change of physical properties of materials as they are refrigerated to the very low temperatures that exist in space, and which exist, of course, in the cryogenic fluids in the Saturn vehicle, presents a great materials problems. And the question of getting materials that will stand up under cold and satisfactorily handle the cryogenic fluids has been a very important one, but has been well solved. Just to give you an idea of what these problems are, Don is forcing liquid nitrogen from the flask through a piece of ordinary rubber tubing. The tubing dips down into the liquid nitrogen. As it goes through, it freezes the tubing and produces a very brittle material out of what is ordinarily considered to be a very soft, pliable material. Don will further demonstrate this by dipping a piece of, again, ordinary gum tubing into liquid nitrogen. And Don, if you may be able to break that. Again, it doesn't sound much like rubber tubing as we know it. There is a second very important cryogenic fluid aboard the Saturn vehicle, and that is liquid hydrogen. Whereas liquid nitrogen is very convenient to demonstrate in the studio, we of course wouldn't do this with liquid hydrogen. Liquid hydrogen, again, looks very much like liquid nitrogen, but it has two important differences. First of all, it is a very energetic fuel. It possesses about 3 times the chemical energy content of gasoline when burned, and for that reason is a very desirable space fuel. But it has a further disadvantage, that it is very bulky. whereas this liquid nitrogen and also liquid oxygen, which are used as the, like liquid oxygen, which is the oxidizer on the Saturn booster stages, liquid hydrogen is very, very bulky, having a density of only about a 15th of that of water or liquid oxygen. And as you notice in the Saturn vehicle, the liquid hydrogen tanks are very, very bulky. Another effect that cryogenics, or very low temperatures, has on gases is to shrink them. And Don has blown up some balloons with his own breath, and when he puts them in liquid nitrogen, the gases shrink down, and finally liquefy, because air will liquefy at liquid nitrogen temperatures. Now, when the balloon begins to pick up heat from the atmosphere here in the studio, the gas is warmed, and it produces just about the same volume as it had in the first place, and these balloons will return to their original condition. Don may have a little bit of a trouble getting that out of his pockets.
Mr. McChandler,
yes.
The main purpose for this, then, is in the development of rocket fuels, as I understand it.
Yes, because cryogenic fluids are compact, it turns out that the cryogenic liquid form of oxygen and hydrogen is the only way in which the required quantities of these gases can be put aboard a Saturn vehicle. If we had to take them on the Saturn vehicle in the heavy steel tanks that you see in garages and hospitals, you would find that the Saturn vehicle is thousands of tons overweight and, of course, would never fly. Don is showing here that as the gases boil off, as you see it boiling in this flask, there is a great expansion going on, and the gas will create pressure. This, again, is a problem that has to be handled in the design of the space vehicle. But again, satisfactory techniques have been worked out, and cryogenic fluids have become, you might say, the workhorse of the Saturn program.
Peter, the moon, of course, has always delighted and fascinated mankind since almost the first night man saw it, and he has coveted it. It has stirred the imagination of many people and all types of speculation about what it is and who lives on it. ABC's correspondent Bill Buttell in London talked to one of Britain's knowledgeable experts on astronomy and on space, the popular commentator Patrick Moore. Buttell asked Moore, why have men always wanted the moon?
Well, I think, that as soon as men realized that the moon really is another world, it was logical to talk about going there. But when we go back 2,000 years, this is Lucian of Samosata, the first science fiction writer in history. Well, it wasn't really science as we know it. He had an idea, which he wrote forward in his book called The True History. And he called it The True History because, in his own words, it was made up of nothing but lies from beginning to end. And in this book, he had a party of sailors going through the Pillars of Hercules, the things we now call the Straits of Gibraltar, and their ship was caught up in a waterspout and hurled upward so violently that it kept on keeping on for 7 days and 7 nights until it finally landed on the moon. And that was his method of space travel. And when they got there, the sailors found they'd arrived at a fascinating time, because the King of the Moon was about to have a war against the King of the Sun with regard to who should have first rights on Venus, the planet, not the goddess.
Well, now, the very idea, the very conception of what the moon was interesting in the early days of man's history, wasn't it?
Yes, well, Plutarch had the right idea there a very long time ago. And he said that the moon is earthy with mountains and ravines. And, of course, he was perfectly right on this. And really, his idea of the moon isn't so very different from our modern idea.
Now, he said it was earthy. You mean like the Earth?
Well, he thought it was more like the Earth than it actually is. The whole point is, surely, that the great difference between the moon and the Earth is that the moon has, to all intents and purposes, no atmosphere. And if you have no atmosphere, you can't have life as we know it. And this, of course, is a thing that the old people just didn't realize and had no real means of finding out. This is a fairly modern development, dating back only a few centuries.
Now, who was it who said that the moon seemed to him to be in the diameter of something like a foot?
Oh, this goes back to the old Greeks, right in the very early days. Mind you, there are some people who still believe that. There's still an International Flat Earth Society, and they believe that the moon is only a few feet in diameter and shaped rather like a saucepan.
Yes. Well, this was one of the first attempts to understand the moon, wasn't it? At least in recorded history.
Yes, I suppose it was. But after all, you couldn't really find out a great deal about the moon until telescopes came along, and that was in the very early part of the 17th century. And as soon as you got telescopes, then, of course, you could start to find out something about the moon's actual nature. And we had science fiction stories then, too. There was one in the early part of the 17th century, written by an English bishop, Godwin.
Yes.
And this is a fascinating story, because in his novel, the hero, Domingo Gonzalez, is marooned on a desert island, and he makes up his mind to escape. And the only way he can think of doing it is to build a raft and then teach gansers, or wild geese, to tow him through the air. And this was duly going on one day, and he was being towed through the air on this raft, when he suddenly made the entertaining discovery that the gansers hibernated on the moon and were very busy going there, taking him with them.
Yes, this was the picture of the gansers taking him, wasn't it?
The gansers taking Domingo Gonzalez to the moon. A very nice idea, but I don't think it's going to work.
Well, who was it who first began to talk about the moon in anything like realistic modern terms? Was it Galileo or Copernicus?
Not Copernicus, certainly. He was in the pre-telescopic